Hello everyone, this is Alan Juarez from USC, and I'm presenting my work with Yehuda Ben Zion on the effects of shallow velocity reductions on 3D propagation of seismic waves. In our poster, we demonstrate that strong shallow velocity reductions can change the amplitude and phase of long-period seismic waves. A common assumption in waveform tomography is that shallow low seismic velocities do not affect long-period seismic waves. Monitoring studies interpret seismic velocity reductions at depth from long-period waves. However, strong ground motions can produce strong shallow velocity reductions, and the recovery is slower than at depths due to the low confining pressure. We try to clarify these assumptions and contribute to the interpretation of observations of dynamic response of shallow soft sediments. For that purpose, we perform numerical simulations of wave propagation for 10 earthquakes randomly located around the LA basin. We use the community velocity model S426 of Southern California, and for each earthquake, we compute a reference wave field using the CVM and a perturbed wave field in a modified model that has a 30% shear wave velocity reduction in the surface of the LA basin. Simulations use the Hercules tool change with frequencies up to 0.25 Hz, 16 points per wavelength, and 400 seconds. We save the wave fields on a grid of 2 km spacing at the surface of the simulation domain. For the data processing, we assume that the velocity variations dv over v and the relative travel time shift delta t over t are related through this equation. We measure time delays and amplitude anomalies in the wavelet phase cross spectrum. Here we can see two synthetic seismograms computed with the reference and modified velocity models. This panel shows the S phase cross spectrum of the pair of seismograms, and here are the time delays calculated from the cross spectrum. The last panel shows an example of time shifts at 10 seconds period. There are clear waveform differences in this pair of seismograms. Time shifts are evident in the coda, and there are also differences in the amplitudes. An important observation is that there are time shifts at periods up to 30 seconds. We validate the measuring technique by performing a one-dimensional checkerboard type test. The test consists of modeling signals with known time shifts and apply the measuring technique. The results demonstrate that the algorithm gives robust measurements of frequency-dependent time shifts. As for the results, we measure relative time delays and amplitude anomalies at 5, 10, and 20 seconds. Here we see the special distribution of relative velocity perturbations for one pair of simulations, and here the average over all pairs of simulations. These results indicate that a strong velocity perturbation can be detected from measuring seismic waves at periods up to 20 seconds. The most considerable velocity variations are estimated at 5 seconds period, but although the velocity changes are limited to the top 500 meters of the LA basin, anomalies are observed in the entire simulation domain. Similar results are reported in seismic monitoring studies that locate velocity changes. The observations can be misinterpreted as changes over larger areas. Also, waveform tomography uses frequency-dependent measurements, and our results show that shallow localized low velocities can produce apparent anomalies everywhere in the model. So inversions could be biased if they do not account for it. For our conclusions, we conclude that the resolution of the analysis techniques and the uncertainties could lead to erroneous inferences that velocity perturbations occur at seismogenic depths, even if the actual variations of the seismic properties are limited to a small volume near the surface. We know that we limited our simulations to a single case, but similar conditions could be expected during the strong ground motions in Southern California. We hope that our simulations also help to understand many of the difficulties faced when developing tomographic models from regional seismic observations at the surface. Thanks for your attention, and please check out our paper in SRL.